Well, good afternoon, citizens of YouTube. This is DK with Mr. V Amps, and you are looking at the contents of a parcel that just arrived to me from China. This is an amplifier kit that uses the single-ended triode 300B, the old Western Electric style tube from the 30s. And we're going to build this kit. I will admit this is not my first foray into this kit. During a few months of absence from YouTube, I did make one of these for a family member, and this is a gift for me for my upcoming birthday. A really, really cool amp. These type of amps can easily cost 4, sometimes 5 figures to own, but this is a much affordable alternative to, put it together yourself. The instructions, which are included, are a little basic, and by that I will show you what I mean when I say a little basic. Let's see what our paperwork is here. You are given a schematic, which is fine, and the schematic includes the updates for some rectifiers here that were not present, I don't believe. I think there's something in this piece of paper too. One of these had a layout diagram. Maybe there's a layout diagram in here. If not, I have the layout diagram. I can print it. Oh, this is all of the resistors. Okay, well that's nice. So the resistors are all packed there. Hopefully there's another piece of paper with the layout diagram. If not, I will locate that. I actually inquired from the previous vendor for some photos of a completed project and the layout diagrams and things, and all of that was provided. So that was great. Okay, this is our layout diagram. It may look a bit like spaghetti, and obviously it's not in English, but we do have some numbers. This is technically, I guess it's upside down, so we'll flip it over. This being your output transformers, your power transformer. You'll have your choke there on top. That's your choke represented there. And then underneath we have our 300Bs and our 6N8P tubes, which are very similar to 6SN7 in US. And then back here, the rectifier tube is 5Z3P, which is very similar to 5U4. So if you do have some US tubes, you can substitute those in. The grounding scheme is sort of a star, all grounded to this center point over here. And the bridge rectifiers that I pointed out in the schematic, they actually physically hang out over here, and they have rectified the voltage to the 300B tubes in order to help reduce the noise, the humming. And there's also these 5-watt large potentiometers that are used for hum balancing. So this is not a rookie build per se, but it's certainly not impossible. This is something that you should be able to do with a little bit of time and effort, and hopefully this video will help you if you wanted to undertake one of these. Tube amps and very good high fidelity sound should not just be for the extremely wealthy people who go and buy these from French manufacturers and, pat themselves on the back for the great stereo system they built. They're building from a much higher level, and they're stacking Lego kits that have already been assembled for them. So we're going to start at the parts level, and these kits are a nice way to start because all the parts are going to work together. It's a proven design. Yeah, so if you'd like, we can get started. the first step you're going to want to do is the chassis here is coated in a plastic that peels off. This is to prevent scratching and tarnishing. So we're going to need to peel that back, at least on the edges, to install the wood end pieces. And they do fit, but they are not drilled. So you will need to mark where each of the holes are, hit those with a twist drill there, put some short holes in there, and there are supplied wood screws to attach these sides. Now, this as an early step would seem a little bit futile, but once you get the power transformer and the other things in here, it's going to be much harder to get a screwdriver to any of those screw holes. So let's do that step first. The screws that are used to attach the wood panels, it is a wood screw. It's fairly short. Okay, so our wood sides are now attached to our chassis. 5 screws, 3 on the edge, 2 on the corners there. Now these are bent pretty well, but the bending could be just a smidgen better, you know. So you may need to take your vice grips or your channel locks and kind of tweak these edges just a little bit before you're ready to put the bottom lid on. But overall, fine. We're going to proceed to, now we have holes here, large holes for the wires for the transformers. So we're going to want to install the grommets in those. Okay, so I've installed grommets for the choke and for both sides of each output transformer. So 5 of them. The ones that are included in the kit are fine, but the type of plastic is a little trickier to manipulate. So I opted to use ones from a parts box that one can get at Harbor Freight. Okay, so the next logical step in this process would be to install the transformers. The power transformer is 4 volts, choke is 2, and remember to run the wires to the outside edge here so they go through your grommet that you installed earlier. The output transformers, the red and blue wire are your primaries, so have those through the front grommet, and the black, green, yellow wires are your output side, so put that towards the rear because that's going to be going back out to the output jacks. Now this next thing is going to be the most important thing I tell you. Just in regards to keeping your frustration level at a minimum. If we look on our diagram here, you will see, this is actually, you're looking at this upside down. If we come out here, you will actually see there is a 1K 25 watt resistors here. These are your cathode bias resistors, and they bolt to the bottom of the chassis. They're large. They're the large ones with the heat sinks built on, and the bolts for those actually go beneath the output transformers. They go beneath the output transformers, so make sure you screw those down prior to putting the output transformers on. Otherwise, when it comes to the time that you need to install those, you will probably be saying things like, "Oh my goodness, this oversight shall impede my progress drastically. I must now remove the output transformers and proceed to install the resistors and then reinstall the transformers." I'm pretty sure that's what you'd say because nobody around here likes to use curse words. Now that we've got the transformers installed, there are covers for the output transformers. They're wrapped in the plastic wrap. I usually save that for a little bit later. You can see the sort of the double screw holes there. That's for depending on which size output cover they send you. We'll probably install the tube sockets next and the rectifiers. The rectifiers, which are not pictured here. I do have some photographs of a completed amp, and again, this is the second time I have built this amplifier, so I do know where those are. Okay, so I've installed some sockets and tubes. We put the RCAs on there, put the banana jacks for the speakers on there. I'm going to put the power plug one on in a minute. I put the tube sockets in, and I put them in the orientation that was shown on the diagram. So pin 1 on the rectifier tube is going that way, and pin 1 on the preamp tubes is going this way. On the 4-pin tubes here are 300Bs. Pins 1 and 4 are back here, and they're the larger of the two holes. So the larger of the two holes are pins 1 and 4, and those are to the back. These are the two rectifiers that are not pictured on the diagram. They do have holes there in the chassis to put a bolt through and bolt them down. The next thing we're going to put on is going to be these large potentiometers for the balance of the filament, and they go in there. But in order to get them in there properly, this plastic knob will need to be trimmed so they can go flat. Okay, so the last thing we got to do before we can heat up the soldering iron, which I may start on tomorrow or maybe tonight if I feel so motivated, we have to get the strip, the wiring strip, that mounted up. Now it comes with some long screws and nuts, and you'll use 3 nuts in the long screw in the 3 different locations. 1, 2, which is going to be our star ground, and then 3, and mount that right up about there. I hope that will enable you to see how it works. There's a long screw installed through, or a bolt installed through the bottom there. You put a nut here to tighten it down to the chassis. The center one, you want it to be quite tight, and you put a nut underneath. Place the terminal board atop there, and then tighten the nuts on the top. The center one is your ground to the chassis, so don't let that one be loose, okay? Okay, friends and neighbors, we'll take a little tour around this in a few minutes, but I have hooked up the power transformer with the exception of the center taps going to ground, because we are going to tie them into the center ground there. This being needing to run on 120 volts as opposed to the 240. They outline 240 here by putting the two 110 volt windings in series. The wires on here are red and black, so there's red, black, red, black. Now to run on the 110 or 120 volts that we have here in North America, you would tie the two reds together as I have on the power switch, and you would tie the two blacks together as I have back here on the neutral. So instead of running them in series, which would tie one red and one black together in the middle, you put the two reds together and the two blacks together. This should give us, between these two, about 6.3 volts, 5 volts, so 6.3 would be on the yellow winding, 5 volts on each of the blue windings, and 800 volts across the high winding. So we're measuring 400 plus 400. We're not measuring to the center tab, we're going all the way across. Should have 800 there. My poor little Radio Shack meter can't measure that, so I went and got the Simpson meter to check that. So let's start. It is hooked up, it is hot, and my center taps are not connected at the moment. My meter is on AC volts, and again, unloaded, this is going to be high. So in a spot where you get 400 volts unloaded, you may very well get up to 500 volts. That's going to come into play a little bit later. So I have the meter on AC volts, and it's allowed to measure up to 1,000 on our high voltage, and it just went kapoofy because I switched it to the wrong stupid thing. It's got to be there. Circuit breaker on this meter instead of a circuit breaker instead of a fuse. How brilliant. Okay. High voltage winding should be 800 volts. I'm measuring 900 volts because it's unloaded. That's 900 volts. Now we're going to go down to a more modest 10 volts so we can measure our filament voltages. The blues should always be approximately 5, and we have 6, again unloaded. This one is 6, this one is 6, and this one should probably be, well, a little more than 6. So let's check that out. 7 volts. So that one's showing is 7 volts. Okay, that's fine. Again, because it's unloaded. So I can confirm I've hooked the power transformer up correctly and I've wired the filaments together. If I were to put the rectifier tube in, I would start to get some pulsating DC B+, but until we build the rest of the power supply circuit, that's not going to be necessary. And I do need to get these center taps grounded for proper function. But anyway, I'll give you a quick tour of what we've done a little bit up closer. Okay, so here's your tour. Over here in this corner are the red and black windings for the primary. I have reds going to the switch, and that sort of, it looks kind of orange. It's more like a, I don't know, a yellowish orange natural copper color. That is going back to the hot of the plug. The commons of the plug are the 2 black wires that are tied together to come back there. So that's our primary. The blue taps are all there, bang, bang, bang. Each of the individual 300Bs will be getting its own rectified DC filament voltage. So that's what these 2 taps are for. Those are full bridge rectifiers. And then the 5 volts for the rectifier tube, which is very similar to a 5U4 rectifier tube. Again, I have to look up the number. The international numbers sometimes evade me. And then the high voltage is going also to the rectifier tube where it can be rectified and then sent to our filtering capacitors and whatnot, which will be mounted back here soon. Okay, kids, so we're building the power supply based on our diagram here. We have 2 47 microfarad capacitors in series. They're 450 volt capacitors in series. 450 in series would basically half the microfarad, so they'd be what, at 23.5 microfarad, and you would double the voltage, so at 900 volts. Remember, we measured 900 volts AC out of that monkey. When we rectify it, that's going to give us probably 900-ish volts, and we are going through a resistor to cut some of the current. There will be a bit of a voltage drop across the 10 ohm resistor. And then that bad boy down there on the next leg is a 500 volt. And actually, most of the DC you come seeing floating around here unloaded is going to be probably over 500. It's like 508, 510, and when you load it up it falls down to around 400 something. That's about what to expect. So these capacitors will be fine. However, you do come to a point later in the circuit. Over here we've got some 450 47 microfarad and 22 microfarad. These caps over here unloaded, they will see 500 and some volts, and they're 450, 470 volt caps. So you have to be careful, and you really don't want to fire this up without any tubes in it on account of that, because those puppies will short and then they'll start to smoke the resistors that they're connected to. So that would be that 4.3K and the 300K. The resistors they're connected to are going to get hot. So we have the 220K resistors over there, as pictured, and we're tied in, and our choke is going from one end to the other, just as in our diagram. There's our 5 Henry choke there and there. Now the grounding point is here. If you notice, the negative of this capacitor is turned in and the negative of this capacitor are here, so the negatives are facing this way. So this is actually a positive out there, and this is a positive out here. Positive, negative, positive, so these two are linked together in series. Okay, I know it's confusing. Let's look at it on the schematic. Maybe that'll make more sense to you. There's our 47 microfarads in series with the 220K resistors jumping them. There's our 10 ohm resistor coming in off the B+, right? And then we come out here through our choke and to our 330 microfarad 450 volt capacitor out here. Okay, so we're coming along, but I have run out of solder on this spool. I have a whole nother spool, but it's starting to get late, and I think I'm ready for a rest. I've accomplished plenty today. Oh yes, I forgot to mention, on our rectifiers I have set up the DC rectification for the filaments. The filaments down here, you go through your full bridge rectifier, and then there is a 10,000 microfarad 16 volt capacitor to take the speed bumps out of your DC, and those go to your 300B tubes. So there are our two rectifiers, and there's 1 and 2 capacitors that are jumping the rectifier. So the positive DC, negative DC are going to the capacitor, and same deal here, positive DC and negative DC, which is hooked to the blue wire, are going to those capacitors. It looks a little scary because when you get this many wires it looks like spaghetti, but it really is what is in this diagram. It shouldn't be too terrifying and scary. And because we are trying to do the star ground, all of the grounded taps from the transformer, so we have the shield and the 0 tap and the 0 tap, shield and 0 tap are coming around, and they are being brought to this central grounding point, which will then be brought to the central grounding point here. So everything's going to ground here. Now what's interesting is on our diagram they didn't connect the earth ground on the power plug. Isn't that a big no-no? Now I connected the ground plug on the one I previously built. It worked fine. I didn't have any noise issues. I wonder if it's quieter if you do leave it off, but I don't want to leave it off. So perhaps if I do find that it's quieter with it off, we'll maybe install our top secret Mr. V silencer circuit in this. Or we could just plug it into the silencer that I sell on Reverb, but it'd probably just be as easy to build the circuit into this amplifier. There's enough room to hide it in that corner, I think. So we'll see. I'm confident this is going to work. It's going to be fun to count all of the jumps along on the turret board. It's definitely a different construction than, say, a Fender amp is, but it is certainly very possible to achieve that and get it to work for you. Alright, so cool. And the cuckoo clock says, "Go to bed, you silly head." That's our filament wires for our preamp. I always thought that was unusual that they made sure they had DC filaments to the 300Bs, but not to the preamp. However, in testing, the other amp really wasn't really a hummer, so I suppose if it isn't broke, we won't fix it. Okay, so the next phase of our adventure is building up our ground bus here. If you look on the diagram, you can see we've got what looks like a square, and then there is a connection over here to that leg over there. So the square would be this right there. So all of these three plus this one need to be ground. And then if you look down the row, there's some jumper wires going to a few different other points down the row that are also ground. So we have a ground over here, and there, and there, and here, and here, and here. And those are provided by the wires that are slotted there underneath the board. And there also is a ground back to here. You can see the blue wire from the capacitors there. That is traveling back to the central point. So you can beep it with the meter if you want to prove the point, but that's part of the grounding scheme. We also need to get our ground back to our banana jacks back here. We gotta ground the neutrals there, the zeros, the black terminals. And we'll have to be prepared to ground the volume pot. But most of the grounds are in place now. Okay, in the process of wiring in the banana jacks to the transformer, which is going to be the green, yellow, black, we all know that the black is the 0, which goes to ground. But how do we know which one's the 4 and which one's the 8? Well, if we look at our diagram, the 4 tap is in the middle and the 8 tap is on the end. So if we just use our ohm meter and measure resistance to the green lead to ground, is, get some connection here, 1.6, 1.7, 1.8 ohms, whereas the other tap is 0.9, 0.8, 0.9. So the yellow tap would be the 4 ohm and the green would be the 8 ohm. Easy as that. Okay, so I made a little bit more progress. You can see the red wire is going up to pin 2 on our 300B tubes there. That is from the transformer, the output transformer. Alright, and we do have all of our banana jacks soldered in there. I guess I can try to take you upside down. Hey, that kind of works. Okay, I'm going to put a wire tie down there and kind of pin those down a bit. And then our cathodes of for the tubes are going through this balancing pot and then up to pins 1 and 4 there, which is the sides of the directly heated cathode. That's the case on both of them. They're mirrored. As far as how that's actually wired, there's our resistor capacitor, which is that, going up to the center pin of the potentiometer, and then each of the 2 legs of the potentiometer go to pins 1 and 4 respectively. Okay, and of course the other side is the same thing in a mirror. That's all hooked up. Alright. Okay, so I'm beginning with the resistors. Things are not exactly going to be mirrored. These being a dual triode, you can they can be flipped and flopped around, so they're not going to be perfect mirrors of each other. We're doing the 1K to the 30K back to the board as shown here, so that's that one. 1K goes from pin 1 to pin 5, so 1 to 5 to the 30K to the board there. And then over here we've got, starting on pin 4, 4 to 2, and then on the 30K back to the board. So 4 to 2, 30K back to the board, and 1 to 5, 30K back to the board. Okay, a little bit more to see. 22 microfarad capacitors in parallel with the 15K resistors on each side. 22 mic, 15K, pin 6 to the board there, and same thing over there. So more progress has been made. Does that look like chaos to you? Maybe it does. This is the world of point-to-point, my friends. There's a lot of resistors in there, and they all hip-hop, skip, jump in and around each other. Alright. And we got some capacitors down there. They are like on the layout diagram. I kid you not. There's a pair of capacitors, and we have our resistors that jump far and jump narrow. It's all according to the diagram. And it looks like that. Now, if it makes you feel better when you're making yours, you can get yourself some sleeving to put on the legs of the resistors if you're concerned about them touching. Now, I have found that they're pretty darn rigid, and once I bend them into place, if they're soldered down well, they really aren't going to be migrating around. So I'm okay with it like this. Maybe you're not, and if you're not, that's okay. We still have to put the B+ power from over here into the amp, and we have to put the B+ power into the output transformers. We have to hook up our inputs and our volume knob and get that information into the grids of the preamp tubes. But we're getting pretty close. Okay, so progress update. We are nearing completion. There's our B+ power. We're going to this channel, the tail end of the 91 and the 470 or 4.7. I gotta double check the values. And then we're back over here to the other leg over here. I opted to use my own wire, and I opted to run it in this manner. You can run it along the chassis, you can do whatever you want because it's your amp kit, not mine. I decided to try it this way. And then the blue wire from the output transformer goes also to that where the power leg comes in there. So you get your power through the output transformer there. Yeah. So, and then the DC filaments there, I came off the DC filaments and went to each of the 300Bs. And now we just have to hook up the audio input. Okay, so I've wired in the volume controls and the ground for over there, and jacks there. I should have grabbed a longer piece of wire. This is a double. This is a double with a shield. I probably should have grabbed the longer one, so I could have gone around instead of over. So if there's interference, we'll change that. They give you these double wires. I did grab some single conductor shielded wire, so I could wire that in over here to the grids of the input tubes. Sniffed around for voltages and things. Everything looks pretty good. Okay, so I have sniffed around for voltages in all of the right places. I did put the rectifier tube in and running at a lower reduced voltage, because remember, the B+ will turn up too high without tubes in here to load it down. Everything looked okay, so I put some speakers on it. We're going to just turn it on. I've got some music from my phone playing from the YouTube library, and I got a variac going, so let's just go up to 50 volts and wait. This is going to be boring. Nothing's probably going to happen. It probably isn't going to make any sound either. I don't hear nothing. Probably isn't going to spring to life till we get to 80 or 90 volts. I would hope I could see some filaments lighting up or something interesting happening. Let's try going up to... Oh, there we go. So I got to like 70 volts. 65, 70 volts. Now I have sound. Let's see, do I have sound in both speakers? Yes. And yes, so both channels are working. So we're running at half of the voltage that this is capable of. But we are working. So this is just some crap from the YouTube music library. So we're working it fine at like 68 volts. Let's try, I don't know, let's try 80 volts. Yay. Still working. Should we turn the lights off so we can see if their tubes are actually glowing? It might look better. That's great. Hell yeah, I can see them glowing dimly. Got a little bit of tube glow there. Oh, now I'm going to need some kind of light to read my variac. Can the camera even see that the tubes are glowing? No, it looks like it's looking at complete and total pitch black. So let's just bump it another, I don't know, 15-ish volts. It's closer to 100 volts, I'm guessing.
Happening out here at Tractor Supply.
Can we see? Now I gotta listen to a commercial.
Summer weather, like kayaks, grills, power equipment, and more.
Maybe I can make my phone turn on its flashlight so I can see.
More on the Tractor Supply app.
There we go. Okay, so we're at 104 volts now. Now we're getting a little bit of tube glow there. Can the camera see the tube glow, or are we just looking at a bunch of dark? You're just looking at a bunch of darkness. Oh well, I thought it would be more fun. It looks more impressive in person, really it does. Okay, so we're running at, as I say, about 100 volts now, 104. So we're going to go up to about 115. That should be about full wall voltage. I think I measured my actual wall voltage here, and I think it's 120. So if I'm at like 115, 117, I mean we're operable. That's what a 300B amp is made to play, crappy YouTube music, right? Now what I need to actually check for here is the hum, because we can balance and eliminate the hum if we turn these pots here. these two little adjustment pots that we have. We can use those to eliminate the hum. So to do that, I just need my flat blade screwdriver to turn the volume to 0. And if I had a big speaker, I could really feel it. But you can essentially just take your speaker, put your finger on the cone, or you could just use your ears. You can do this in real time while there are speakers hooked up. You're not going to blow anything up. And you can just turn that and you'll either get more hum or less hum. Okay, there's more coming that way. You can feel we're going less. I'll probably do this again when I get to the real speakers. And it's coming back up again. So it seems like right about there for this one was about the lowest. Felt like right about there. And then we'll just do the same for the other one. Let's see. That one feels like it hasn't really got much hum at all. And again, these speakers are not in a box, they're just laying on the bench, and they're garbage speakers out of a car, like stock speakers from a car. But they're 4-ohm speakers that if anything bad happens to them, I don't care. And again, I'm just feeling for the low level hum. Seems like right about there is pretty close. So that should be about right. Now, early in the video, I mentioned about the chassis sort of bending and everything. The holes for the bottom cover plate, which I do have on with a few screws, again, not quite lining up as nicely as I'd like it to. So I'm probably going to have to squeeze and press a little bit just to get everything to line up to get the screws in the first time. That's kind of a penance of this. These are actually different. The first tubes they sent me on my previous kit had the Lian Lai brand on here, and these came in the same Lian Lai boxes, but I think these say like Una something or other. They're a different branded tube. And the top here, this is really interesting with these little coils. But boy, this little puppy's a space heater. We're probably not getting the full 7 watts because my phone does not have much of an amplifier in it. But that's about all it takes to construct one of these. I guess I can leave it cook for a while, just enjoy a little bit of background noise, put some music on that I actually care about let this cook for, I don't know, 30, 40 minutes. And if everything passes, then I will finish putting the bottom on, set it up on my stereo, and enjoy it. These are a really good sounding amp. I like them a lot. Yeah, I'm happy. I don't know what else to tell you. If you want one of these kits, then you know, go find one on AliExpress. They advertise these as 300B, 3H8C, and then I think the rectifier was what, 5Z3P or something like that. But you know, you'll find this kit, and you can pick them up there. It's probably going to cost you about $6.50, I think was the best price I was able to find on these. So it's not a cheap kit, but it works.
Rain jackets at Sierra.
And I think my camera beeped at me. Anyway, thanks for watching. Have a great day.